Boleh dengar tak?
Boleh. Dengar.
Dengar, boleh.
Okay. Saya cuba handphone ni untuk connect dengan ni, dia tak nak pergi. Dia rasa ni kot, Celcom kat atas ni. Celcom Kong apa ni. Tak nak, dia tak nak. Pelik tak masuk langsung. Telefon ni keras pula. Okay, so kita teruskan. Kalau tak nampak, beritahu kat saya lah. Saya main cakap je lah ni, saya tak nampak apa pun. You all apa yang you nampak ya. Okay, Assalamualaikum warahmatullahi wabarakatuh. Terima kasih boleh dengar semua suara saya. So kita today, we finished already this chapter 3. So today we are going to do on chapter 4. Okay, so I'm going to share my screen. Okay, just let me know if you cannot see how you're supposed to see the PDF on the chapter. Apa tu nama? PowerPoint ada chapter 3. Chapter 4, sorry again. Chapter 4, so I'm going to share now. I'm going to share now. Nampak tak?
Nampak.
Okay tak ada apa I mean nampak tu. Nampak tajuk dia. Okay, sekejap Sekejap. Baik, saya apa pula? PowerPoint tak boleh buka. Aduh. Ya, saya share semula. Baik. Nampak?
Nampak.
Okay. Terkejut saya. Okay, so chapter 4 factor affecting the polymer chain structures differences. Alright. So chapter 4 ni kita akan tengok the faktor-faktor yang menyebabkan polymer chain structure tu different. So faktor antara faktornya ialah the conformation, stereoregularity of the structure, the polymer structure, which is about the tacticity ataupun isomerism. So the third is the branching ataupun the cross-linking of the polymer. And number 4 is the interchange forces that each of the polymer, rantai polymer tu having that. Okay, so on the conformation, it is about the flexibility or rigid types. So the terms of configuration and conformation are used to describe the geometric structure of the polymer. So configuration ni ialah merujuk pada order that is determined by the chemical bonds. Meanwhile, the conformation is the order that arises from the rotation of molecules about the single bond. Okay, so untuk yang configuration, so familiar ni cis and trans. So ni ada dalam polymer lah. Polymer, for example, the natural rubber punya rantaian. So the two type of polymer configuration are cis and trans. So this structure cannot be changed by physical means. For example, dia cannot berubah walaupun kita buat the rotation. So dia adalah configuration arise when substituent group are on the same side of the carbon-carbon double bond. So siapa yang masuk kemudian tu boleh masuk sebab saya tak tahu kalau tak guna UiTM punya itu mungkin tak masuk sebab saya tak boleh admit sebab saya tadi buka kat phone. So the trans refer to the substituent on the opposite side of the bond. So this is the cis. Cis dia adalah on the same side of the carbon double bond. So dia berada pada side yang sama. Okay. So untuk trans dia opposite. Okay. So ni macam mirror image lah. Dia opposite. Alright. So okay, conformation, if two atoms are joined by a single bond, then rotation about the bond is possible since unlike the double bond, it does not require the breaking the bonds. Okay, and then the ability of an atom to rotate this way relative to the atom which is joined is known as the adjustment of the torsional angle. So if the two atoms have another atom or group that attached to them, then configuration which vary in torsional angle are known as the conformation. So since different conformation represent the varying distance between the atoms or group rotating about the bond, and this distance determine the amount and type of the interaction between the adjacent atom or group of different conformation may represent different potential energy lah untuk molecules, polymer molecules. So yang kedua ialah faktor yang kedua ialah stereo regularity of the structure. Okay, so kita tahu dah kan stereo regularity ni polymer yang mana dia punya susunan kumpulan yang attach pada main chain dia sama ada secara isotactic, syntactic or atactic. So a polymer which chain configuration dia consists of a small regularly oriented unit in a single sequence arrangement. So termasuklah isotactic and syntactic polymer. So we have already tengok sebelum ni, for example in the structure of polystyrene. So the different arrangement of this tacticity produced ni akan influence dia punya properties of the polymer itself. Okay. So we have the isotactic arrangement of benzene ring, syntactic and atactic in the case of polystyrene. So isotactic PP for example pula versus the atactic PP. So for the iso susunan dia isotactic available secara commercially lah. So yang kalau kita tengok dia akan letak dengan small I indicate by small I. So dia akan tu PP, highly crystalline this material which is having the temperature or melting temperature of 160 degrees Celsius. Meanwhile for the atactic means that randomly arrangement of CH group tu secara random on the main backbone. So dia appear ataupun dia exist as a amorphous which is non-crystalline. So this is the very soft polymer which is the TM is about the 75 degree Celsius. Okay, so next is the branching and crosslink. Okay, branching and crosslink. The third factor branching and crosslink, branch polymer. Branch polymer ni kita tetapkan polymer tiada kalau kita classifykan polymer ni dia ada polymer according to their structure ni, kita ada secara linear, kita ada secara slide saya bertukar-tukar kan, dia nampak kan. So kita ada secara linear, kita ada branch, kita ada star, kita ada network and interpolating network. So kita tahu this is the polymer chain lah. So dalam polymer chain kita ada yang classifying according to their chain structure ni. So means that to define polymer ni based on the way chain or monomer dia connected together. Okay, so they connected secara linear ke, secara branch ke, secara star polymer chain ke. Okay, so as this define many of the polymer lah attribute to the property, dia akan attribute to the dia punya properties. So linear polymer chain, okay, so kita tahu kan almost semua exclusively thermoplastic lah, ya, yang mempunyai linear. So normally, okay, so kalau macam ni branch and cross link, kalau branch main ni dia punya yang main, lepas tu kita ada yang sisi dia. So the side is the branch. So body branch polymer is formed when there are side chain attached to the main chain. So side chain attached to the simple example of branch polymer is known as the following diagram ni dia kata. So maknanya kita ada yang ni and then kita ada yang sisi-sisi dia ialah, so yang sisi-sisi dia ni ialah yang ni lah, ya. So it's like macam pokok lah, ada main, trunk and then kita ada branch. So untuk yang tapi kebanyakan polymer, linear polymer chain lah most exclusively adalah thermoplastic. Okay, so kalau kita tengok yang linear normally kalau you tengok bukan dia akan buat macam ni kan, tu maknanya linear. So ada pula satu lagi linear chain juga. So ini menyebabkan kalau untuk linear ni dia easily to side pass one another. Okay, dia boleh mudah lah untuk kita untuk pass one to another. Okay, maknanya kalau kita ada banyak rantai polymer tu mudah untuk dia dipisahkan. Okay, so dalam polymer tu kita tahu kan, we have the polymer. So setiap satu tu adalah ada hidrogen, ada carbon. So dia akan, normally you akan tengok kan banyak gambar dia tu sudah bentuk zigzag tu. Okay, so ni ialah to minimize the hydrogen impact on the one after another. So yang tadi yang kita tengok macam selalu ada bertanduk-tanduk, berbulat-bulat tu kan, kalau dia ada macam ni, dia ada attach lagi. Okay, so dia akan sambung lagi dengan polimer lain dan monomer lain. Okay, so beside that we have the branch tadilah yang kita tengok before this branch. So polymer chain untuk branch ni dia branch polymer chain structure ni usually thermoplastic juga, tapi dia depends on number. Okay, depends on the number, length and cross linking ataupun apa yang ada kat situ. So dia macam like tree lah. Okay, so kalau untuk branching tak nampak lah benda Allah kecil ni. Okay, so kalau branching kita ada polymer chain yang tu, and then dia akan datang sini branch. So dia akan datang branch dekat ni. Okay, tekan lagi ni ada. Okay, so dia macam pokok lah, ada pokok dia, ada terang, ada ranting dia. Okay, so itu ialah branch polymer. So kalau untuk next apa, star polymer chain. Okay, star polymer chain. So kalau star polymer chain ni dia macam ada satu punca kat tengah ni, so macam star lah, dia growth. Okay, and growth. Okay, so star polymer chains either dia boleh jadi thermoplastic or thermoset depending on dia punya number, length and cross linking of the branch dia. Okay, so ni ialah central monomer lah kat tengah-tengah dia ni kan. Hilang aja benda ni. Okay, ni central monomer dia kat tengah-tengah ni. Okay, so next ialah polymer network. Polymer network ni almost exclusively belongs to thermoset. Okay, so belong to thermoset. So dia network lah, dia akan padat. Dia macam noodle structure tu. So dia akan ada sama ada secara covalent atau non-covalent, dia akan lengkapkan dia rantaian polimer. So last ialah interpenetrating polymer network. Okay, interpenetrating polymer network. Okay, polymer network interpenetrating ni normally dia akan ada polimer satu, polimer ada network lah, maknanya macam kita kalau buat network tu maknanya ada benda lain lagi. So dia akan intertwine lah between kalau ada dua tu. So kita tengok ni gambar dia. Okay, so ni tadi branch. So kita tengok sekarang. Okay, kalau linear kita pakai ni lah, payah. Okay, kalau linear ni, dia linear je lah tadi straight je. So kalau flat coil, dia secara flexible coil lah, so easily to pass to each other. So most of them belong to thermoplastic, so the cross link. Okay, slowly, macam ni lightly cross link, ni dense, dia lagi padat lah cross link dia. So ni interpenetrating network lagi complex. So dia ada network yang katakanlah ada dua jenis. So interpenetrating network ni untuk yang satu polymer network satu, polymer network dua, macam tu. Okay, so dia akan bersilang-silang lah dalam tu. Alright. So kita ada tadi yang branch tu, so kita ada yang main kat sini, so kita ada branch. So kita ada random long branch, kita ada regular cone branch. Okay, macam sikat bentuk dan ni tadi star branch dia secara star branches. Okay. Alright. So branching and cross linking ni, so kita tengok tadi how there are however many ways a branch polymer tadi can be arranged. Okay. So kita ada secara star branching. So kita ada star branching, kita ada satu kat tengah ni dia punya dia punya central monomer dia, and then dia akan mengembang. So ni membentuk star lah. So star branching result when polymerization start with a single monomer. So single monomer duduk tengah-tengah ni. Okay, and has branches secara radial outwards. Dia radially terkeluar secara radial keluar from this central point. So polymer with high degree of branching, kalau banyak sangat degree branching dipanggil sebagai dendrimer. So often in these molecules, branches themselves have branches. Dia ada lagi branch ni pun ada branch lagi, and this tends to give the molecule and overall spherical shape in 3 dimensions. So dia macam dah jadi bentuk bola, spherical. Okay. Alright. Kalau linear tadi, part of a linear polyethylene molecule, part of the branch polyethylene molecule. So dia ada branch. So kalau kita tengok branching, linear PE has a melting point of 2 degrees Celsius higher than the branch. So dia lagi stabil, so lagi kuat. So linear chain can pack in regular 3D fashion. They form a crystalline phase. Meanwhile, while part of the HDR stay tangled in the amorphous space. Okay, high branch polymer is incapable of this due to the random location, Okay, and dia punya length of the branch akan menghalang dia, prevent it from the buat regular packing. So low degree of branching also have degree of criticality but lower than dia punya as compared to the linear lah. Okay, so due to the regular arrangement and tightly pack of the chain in crystalline region, linear PE is often called as the HDPE. So dia punya high density lah. Dan yang slightly branch material tu low density polyethylene. So dia punya segi properties such as stiffness, strength, optical clarity affected by changes in dia punya crystallinity content. That are the because of the subsequent case of the subsequently because of the different of dia punya branching. Okay, so branching crosslink ni dia ada tadi kan kita dah tengok short branching, pendek-pendek je, long branching yang panjang dan juga starlight, dan kita ada comb light juga. Okay, so ni ialah copolymer. Okay, kalau macam ni ialah random copolymer, contains a random arrangement. Yang ni ialah block copolymer. Okay. Dan ini ialah a graph copolymer. So untuk yang block copolymer contain block of monomer of the same type. Graph contain a main chain polymer consisting of one type of monomer with branches made up of the other monomer. Okay, so kalau cross-linking, having the cross-linking in the polymer menyebabkan it do not melt upon heating. Okay, dan dia juga stable, so it's not easily dissolved. Okay, in the solvent, but sometimes dia hanya swell je, dia hanya bengkak je, dia hanya mengembang in the compatible solvent lah, tak semua. Okay, so untuk the hydrocarbon, so the bond which hold the monomer together in the polymer chain, and many polymers form bond between the neighboring chain. Okay, itu yang dipanggil sebagai cross-link. Okay, so this bond can be formed directly between the neighboring chain, or two chain may bond to the third common molecule. Okay, so dia bersilang-silang lah, nama pun tahu silang. So katakanlah kita ada rantai polimer 1, rantai polimer 2, 3. So dia akan disilang, ditauk silangkan. So dia akan form the crosslink. So though not as strong or rigid as the bond within the chain, these crosslinks have an important effect on the polymer properties. Okay, polymer with high enough degree of crystallinity, dia akan ada memory. Means that kita usik dia boleh balik pada tempat asal dia. When the polymer is stretched, crosslink prevent the individual chain from sliding past to each other. So sukar untuk kita rantai dia tadi. Kalau macam linear tadi kan, kita easily untuk dia move, untuk kita slidekan dia to pass each other. So the chain may be straightened out, but once the stress, okay, kita pull dia, once kita remove, macam you buat tensile tu lah. Kalau buat tensile test for rubber kan, cuba you ambil sampel tu, you stretch rubber tu, rubber yang dah vulcanized tu, and then you release, dia akan back to dia punya original shape dia, if dia dah belum sampai dia punya tahap putus lah. So they akan return to their original position, and the object return to its original shapes. Tu yang dikata ada memory tu. So one example of crosslink is the vulcanization lah, which is based on the crosslinking by the crosslink agent yang kita panggil sebagai sulfur. So crosslinking tends to increase the Tg and increases the tensile strength and the toughness. Okay, so cross-linking consists of the formation of chemical bond between chain. Okay, so kalau kita ada branching, kita and crosslink, kita compare kat sini. So kalau branching straightforward lah. So dia ada polimer-polimer, so dia monomer-monomer, so dia terhubung secara branch. So yang main, so kita ada yang branch datang. For the crosslink, kita ada polimer ni banyak-banyak. Okay, when polymer are crosslink, so a bunch of chain all become one big molecule. So dia ada banyak rantai polimer and then kita form the crosslink kat sini, yang biru ni datang sebagai crosslink. So kita akan dapat satu molekul yang besar. Ya. Okay, so kita tengok the branching and crosslink, perbezaan dia. So the process of branching polymer occurred due to the high rate of polymerization lah. So the formation of branching ni berlaku during the process formation of the polymer itself, iaitu polymerization process, which means is not due to the agent. So kita tak pakai apa agent. So the structure is stiff dan is characterized on the maknanya branching ni kita kategorikan dia in terms of the number of branching dan juga size of the branches. So meanwhile, for the cross-linking polymer needs agent. So for example, just now we said that the natural rubber to form the vulcanization process, crosslink, untuk impart the crosslink, so kita apply the sulfur. Kita guna sulfur, which is the agent for the cross-linking with the presence of sulfur tadi must be under pressure and the rise of temperature. So cross-linking to connect the polymer chain with another chain. So the structure is more flexible with low crosslink density, tapi kalau high crosslink density, yang terhasil tu adalah polimer yang lebih keras lah, lebih rigid. So it characterized by their crosslink density or degree of crosslink kita panggil. So berbeza dengan branching tadi kita characterize in terms of dia punya number and size of the branch. Okay, so for today kita berhenti dulu kat sini. Kita jumpa lagi akan datang. Okay, so saya stop sharing. I end this